Okay, today I thought we'd play with and talk about the Sonicon robot. And this toy came out in about 1960, 61, let's just say early 60s. And it's a tone control toy. You remote control it with a whistle. And it does this mechanically. There are no transistors or tubes involved in this. I've done videos in the past showing how you can build this Helmholtz resonator circuit that does this, and I think we're going to start with just the demo of it because some of you just want to see the toy work. Then I'll proceed on with explaining how it works and giving you links where you can see build videos and stuff like that. So if you're not interested, you don't have to watch the rest of the video. You can just get the good part out of the way. Now, the original toy had a whistle. This is not the original whistle, I guess is what I say. This is one that I 3D printed that produces the correct tone. The original whistle was not given to me. This toy was sent to me for repair. And the radar dish sticking out of the top of it is not the original radar dish. I don't know if the owner of this toy has the original radar dish and whistle or not. All I know is I received the Sonicon Rocket for repair. So I had to make these up in order to play with it, because you can't test it without a whistle, and you don't know what direction you're going to go in without the antenna, because the antenna points in the direction of the drive wheels underneath. So you need all that good stuff. Alright, here's a switch on the side. You see, it's going to go in the direction the antenna points. And it's ignoring me right now. And you'll notice that the tail lights would light up every time that it picks a new direction. Okay, so that's the basic gist of the toy. All of you that wanted to just see the demo of it moving, you've now seen that. We're now going to move the camera around and talk about how it works, hopefully. So hang on, I'm bumping you around, I know. Let's put this right about here. Okay, so as previously stated, in order to work on the toy, I needed the correct tone whistle, and I needed an antenna that would tell me the direction I was moving. And the toy itself, the batteries have just dropped out of the bottom. That's fine. Takes 2 D-cell batteries. You can see there, the on-off switch is a very cool lever right there. You've got a little guy in the cockpit. You've got your tail lights. Sound can get in through these holes and through the main vents, which go to the Helmholtz resonator in the bottom. You've got a motor-driven drive, which has a ratchet. When the toy is sitting like this, that locks. It won't turn this way, but I can turn it this way, and you can actually hear the ratchet lock. And the reason there's a ratchet like that is because there's only one of these 2 wheels that's driven by the motor in here, and it's this one. So when it's going forward, it's pushing against that ratchet, so it locks it, and it's going to go whatever direction it is. But if you reverse this motor, then the wheel would tend to spin in place. So that's why they put a ratchet on there. So to do all the control, all they have to do is have the motor run forward or backward. I'm going to have to get into the insides of this a little bit. So let's move the camera where you can see the computer screen, and where I can see if the camera is seeing the computer screen. So this is a picture of the inside of the Sonicon Rocket. Now, when I got it, the toy had a lot of problems. There were broken wires on the inside. People have been into it multiple times. inside this black box right here, there's a very sensitive relay, and this had separated, and the relay was out here banging around out in the open, which probably explains why some of the wires were broken off. And also down in here, which goes to that drive motor assembly that we talked about, there was a cold solder connection on the motor inside that drive motor assembly, and so the motor was very intermittent, would work sometimes and not work other times. Now, so the motor's here, your two D cells are here, there's a relay here, and this strange looking contraption is the Helmholtz resonator. Here's more of a close-up of the relay, top of the battery box, and your Helmholtz resonator. Basically think of it as a can or a drum, has an opening at this end, and up here there's a little wiper that just gravity pulls it down to make a connection to the can. It's isolated here, so it's just a switch. And normally, with nothing happening, the wiper would touch the can, that would close the switch. When the Helmholtz resonator, when a tone enters this chamber of the proper frequency, it resonates, and that'll cause the two contacts to vibrate. The switch will be opening and closing. Out of focus, it's more of a close-up of that. Just showing the inside of the switch. There's something very special about that switch, which we're going to talk about. This is looking straight down onto it. Because the complete motor does rotate, it gets one side of its power from frame ground, but it has an isolated wiper delivering power to that motor right there. And there's a beauty shot to the side. Let's go to up on Thingiverse, up on YouTube. Here's a build video I did. Make a Helmholtz resonator detector switch detect sound without ICs or transistor circuits. Now I showed how you could make one of these and how it works. And this is a very good video for all of that, and I will keep that link in the description of this video, because also in this video there'll be links to an actual Sonicon tone controlled robot that I built, and there'll be a link to this page, which is on Alphadrome, where I show some of the patents from 1955. In this case, this one was filed in 1956, I guess, showing how they were making a Helmholtz resonator and the switch and how it works. And in that particular patent, they were putting it inside a little cart, a little car type mechanism. And I also show some of the different toys that have used this tone control. Here you can see what the original whistle kind of looked like, and here was a car that you controlled with a Sonicon patrol car. And you've got the space vehicle, you got the buses, you've got the Golden Sonic, which used a very strange looking whistle. But this is a link, which is if you ever go up to Alphadrome, then go into the patent section, and in the patent section you can find where I put in hundreds of patents for classic space toys and stuff like that. But you can also find the 1955 through 61 patents for the Sonicon toy control. So here is a very crude, I got to get it where both the camera and I can see this at the same time, schematic of basically what's going on in there. Let's start over here with the two D-cell batteries. In a normal toy, we've got two D-cell batteries. The toy is going to be running on 3 volts, so they would take this battery and connect it directly to this battery, which means here you would have +3 and here you'd have your minus. In this particular case, the motor that's driving the unit, the one that can rotate around, it only runs on 1.5 volts. When it's going forward, it's going to be running on one of these batteries, and when it's going in reverse, it's going to be running on the other battery. So what they had to do, and the lights and the relay and all the stuff we're going to talk about next all run on 3 volts. So they put the on-off switch, which is actually 2 switches. They're 2 single pole, well, it's 2 poles, single throw. This switch basically shorts the two together, like I said, in a normal toy that's going to run on 3 volts. But they need a tap off for that for the motor, but it can't be connected all the time, so there's another switch that would then connect one side of the motor to this connection. That way this side of the motor could either go positive or negative depending which one of these you connect to the other side of the motor. And that choice is going to be made by a relay. Now a relay is just a switch that can change its state from on or off, open or close, based on when a coil is energized. It just pulls a piece of metal down, which is the same as flipping a switch. So in this case you've got your positive and your negative going to two poles of the switch, and there's another wiper that can either touch this one or when it's energized can touch this one. So no power, these two are connected, power applied, these two are connected, and it just swings back and forth magnetically. So that's how the relay is going to tell the drive motor whether it's going to be running the thing forward or rotating a disc, turning one direction, turning the other direction. So it comes down to what's going to control that coil in the relay. And that's where the Helmholtz resonator comes in. Like I said earlier, it's basically just a chamber. It's open on one end, and it'll have a diaphragm on the other end. In the case of these Sonicon toys, the diaphragm, in fact, is metal. So they'll make one side of this whole drum connected to the power supply, and then the little wiper finger that touches it is the one that's going to go directly to the coil in the relay. Normally, when there's no sound applied, these two are touching, so the relay will be energized, will be on. And that's your drive forward type thing. Well, when a tone enters, the contacts here start vibrating, and the coil in the relay doesn't like that. When it sees that vibration, that's like a duty cycle control. So the coil will then unenergize and release as if it wasn't getting power, and that reverses the motor, and that's when the motor turns around and selects a new direction to go. Now they've tied into that whole same system the two tail lights, so that whenever it's in that tone mode, the two tail lights would then light up and give you that function. The whole resonator device, Helmholtz resonator can, has to be isolated from the frame of the tin toy for electrical reasons and also mechanical reasons. So it's mounted on rubber grommets, which remove the vibrations from the drive motor or the floor or anything like that, causing these two to vibrate and not work properly all the time. This is covered in greater detail in my video. For example, on this video right here, we can click on that.
How to kill all mosquitoes in the area.
Of course, they make you watch an ad. I don't get any money from YouTube at all. Everything I do is for free. But in here, it's going to go all the way through and talk about the Helmholtz resonator that's used in the Sonicon bus toy, because when I made this video, that's what I had, was the bus toy. And I do draw schematics, but near the end here, I actually show a Sonicon robot, which I built with my own Helmholtz resonator, which I made from a, I went to the dollar store and they had these little metal containers, I think you're for putting paper clips in and stuff you might have at your desk. And it already had a clear top, I guess, so you could see what's in there. Well, I'm using that clear top as a resonator, so I just cut a hole in the bottom to let the tone in. And I had to experiment a while to get the chamber tuned the same as the whistle that was used in the Sonicon, but eventually got it there. And in fact, I ended up using a paper clip to make the little wiper that completes the circuit. Anyway, that's all covered in the video, in case you want to build your own or see how it's done, or want to actually see the thing in action. So underneath there, when you get down here where it shows more, this is where I've got, if it's on camera, let's turn this a little bit more that way. This is where I show a lot of different ones. You click on this link if you want to see the Sonicon Robot project. Radicon Robot can be found there. It goes on to other things. Courier, meter based, battery checked, Thingiverse files for all kinds of different files there. So you might find this video interesting. And you definitely should find the Sonicon Rocket interesting. It was a very advanced toy for the time to be able to control it with the tone of a whistle and steer it in any direction that you want to go.